Welcome to our channel Sankalp Study Success. So today in this video we are going to learn about congruence arithmetic properties. We are having three congruence arithmetic properties. So let us see one by one. Here is the first property. If A is congruent to B mod M, here this is the given data. A is congruent to B mod M. So if A is congruent to B mod M, then if you add or subtract C on both sides. That means if you add C on both sides or if you subtract C on both sides, then you will get the first property, A plus or minus C is congruent to B plus or minus C mod M. So let us prove here. First of all, A is congruent to B mod M. That means A minus B is divisible by M. It is divisible by M. That means if this is divisible by M, so if you add or subtract C on both sides, then what happens? Let us see. We are adding C to A and also subtracting, and also we are adding C to B and also subtracting. So let us write the equation for adding C. That is A plus C minus B plus C. That is A plus C minus B minus C. So, if plus C and minus C gets cancelled, we will be remained with A minus B. And also, take the next equation by subtracting C, A minus C minus B minus C. So, here A minus C minus B plus C, it becomes. So, if you cancel plus C and minus C here, we will be again remained with A minus B. So, if you are adding or subtracting, you are getting A minus B only. That means what? If this A minus B is divisible by M and also we got A minus B and A minus B, that means if you add or subtract C on both sides, then also it is divisible by M. So, we can say that A plus or minus C is congruent to B plus or minus C mod M, right? So in this way we got the first property. So let us once see here. We already know that this is A is congruent to B mod M, and from this we can say that A minus B is divisible by M. So now here we are adding and here we are subtracting C to both A and B. So we got A minus B and A minus B. That means what? Here we are subtracting and also adding C on both sides. So we are getting the same A minus B, which is again divisible by M. So this property goes true. So this is the first property. But now let us see the second property, which is again AC is congruent to BC mod M, which is again proved with the same equation. A is congruent to B mod M. So let us write here A is congruent to B mod M. That means what? A minus B is divisible by M, which we already know. Now, if you multiply C on both sides, that means what? You can multiply C to A minus B, right? If you multiply C to A minus B, then what is C here? C is nothing but it is a positive integer. So, if you multiply any integer to A minus B, then it is also divisible by M. So, now A minus B of C can be written as AC minus BC, right? That means we are just multiplying C inside this parenthesis. That means we got AC minus BC, which is divisible by M. It is divisible by M. That means what? If this is divisible by M, how can you represent this one? We can represent it as AC is congruent to BC mod M, right? So we got our property. So let us see here. A is congruent to B mod M is nothing but A minus B is divisible by M. And if you multiply C here, so you will get AC minus BC, which is also divisible by M. That means AC is congruent to BC mod M. Here there is a note which is very important, which is here we have learnt that if A is congruent to B mod M, then AC is congruent to BC mod M. But vice versa will not be correct. That means what? Converse of 2 is not always true. That means if AC is congruent to BC mod M, then A need not be congruent to B mod M always. That means always it is not true. Maybe sometimes it might be true in some cases, but it is not true in each and every case. So this note is very important. You need to remember this point. So now this is the first property. So let's go into the second one. Here, if AC is congruent to BC mod M, then A is congruent to B mod M. We have just now seen that if this is congruent, then A need not be congruent. Here it is written that it is need not be congruent. Here we are saying if this is true, then this is also true, but with a condition. Only if. What is that condition? Here it is written that GCD of C comma M is equals to 1. This is the condition. If GCD of C comma M is equal to 1, then only this statement is true. Otherwise, it is not true. So, here, if what is C here, then GCD of C comma M is 1. Let us write here GCD of C comma M is equals to 1. Here, C is nothing but it is an integer and it is dividing M. That means what? GCD of C comma M is equals to 1. So, we have to prove, we will get this equation. So, we need to prove this equation. When, if this is true, then we have to prove this equation. So, let us write if AC is congruent to BC mod M, then that means what here? This is nothing but AC minus BC is divisible by M, right? We can also say that it is a multiple of M. Multiple of M or divisible by M, both are one and the same, which are nothing but multiple of M. So, how can you write it? How can you represent it in the form of equation is AC minus BC is equals to PM. Here P is not, as it is a multiple of M, P is nothing but it is just an integer. So here if you take C common, A minus B of C is equals to PM. Now taking C to the RHS side, you will get P of M by C. That means what here? A minus B is divisible by M by C, correct? And also you can say that C divides M. So if C divides M, then GCD of C comma M will become 1, right? Which is already given in the question here. GCD of C comma M is equals to 1. If that is GCD of C comma M is equals to 1, we have proved it here. So if this is equal to 1, then A is congruent to B mod M, right? Why, if this is equals to 1, then why is this true? Because if you substitute GCD of C comma M as 1, then it again becomes the same equation, right? A is congruent to B mod M. So in this way you can prove that if AC is congruent to BC mod M, then you will get A is congruent to mod M by GCD of C comma M. If GCD of C comma M is true, then only A will be congruent to B mod M. Otherwise, you have to substitute the value of GCD of C comma M in this equation. Okay, you are clear, I think so. So let us go into the third property which we have, which is the last property here. This might look something similar to your first property which we have already discussed. These three equations, I think these two equations are more similar, right? Here it is given that A plus or minus C is congruent to B plus or minus D mod M. If you remember, in the first property, we were adding and subtracting C on both sides. But here, we are adding and subtracting C to the LHS and we are adding and subtracting D to the RHS. So, there is a slight difference. So, let us prove this. It is given that A is congruent to B mod M and also C is congruent to D mod M. We are having two equations. Let us write it here. B mod M and C is congruent to D mod M. So, from these equations, you can say that A minus B is divisible by M and here C minus D is divisible by M. So now, if you combine these two equations, if you add or subtract those two equations, a minus b plus or minus c minus d, then what do you get here? A plus or minus c minus b plus or minus d, right? These two are one and the same. So if this is divisible by m, then this is also divisible by m. So you can represent this equation as a plus or minus c is congruent to b plus or minus d mod m. This is the equation which you can represent it. A plus or minus c is congruent to b plus or minus d mod m. This is our first proof, right? See here. Hence, A is congruent to b mod m and c is congruent to d mod m. Then you will get a plus or minus c is congruent to b plus or minus d mod m. So this is the first proof which we have. Now let us prove the second proof, which is AC is congruent to BD mod m, which is also again similar to the first property, but there we were just multiplying C on both sides. Now we are multiplying C as well as D on both sides. So let us see. We will again prove these properties with our own equations which we have. A is congruent to B mod m. So from here you can say a minus b is divisible by m, and also we are having the second equation, c is congruent to d mod m, right? That means c minus d is divisible by m. So here you can say that if you combine these two equations, we will get the first property. So here what do? A minus b is divisible by m. We already know that. So we will just multiply c with this. So this will be divisible by m, right? Here c minus d, we will just multiply b here, which c is nothing but any integer. Here b is nothing but any integer. So if you multiply any integer, it will again divisible by m. So now a minus b of c plus c minus d of b. If you combine these two equations, then what does it gives you? AC minus BC plus BC minus BD, right? Now, if you cancel plus BC and minus BC, then you will get AC minus BD. You are remained with this, right? This is again divisible by m because we have already combined these two equations, which is divisible by m, and by simplifying this we got AC minus BD, which is again divisible by m. Now if you represent AC minus BD as in the congruence manner, you will get AC is congruent to BD mod m. So we have proved our second proof, right? Second property. See here. Here we have this equation. From this you can say a minus b is divisible by m. Now we are just multiplying c to a minus b. This is also divisible by m. Now c is congruent to d mod m. Here we are multiplying b here. Now combining these two equations, we will remain with AC minus BD after simplification. So you can represent AC minus BD as AC is congruent to BD mod m. So this is the second property which we have. So let us go into this last property here so that we can move into problems and we can discuss few examples. Here comes AX is congruent to BX mod m, right? Here we need to prove that property a power x is congruent to b power x mod m. It is not ax or bx, I'm sorry. So we know that a is congruent to b mod m, right? So now if you square it on both sides, squaring on both sides, then you get a square is congruent to b square mod m. Now if you again add one more power to the previous equation, then you will get a cube is congruent to b cube mod m. In the same manner, if you again add one more power, then you will get a power 4 is congruent to b power 4 mod m, right? So in the same way, if you go on adding like this, then you will be remained with a power x is congruent to b power x mod m, right? So here, what is this x represents? Where x belongs to integers, because here you are just adding 1, then again you are adding 1 to 2, again you are adding 1 to 3, so that it goes on and it will remain up to a power x is congruent to b power x mod m. So here x is a positive integer. Okay, x is a positive integer. See here, we are just squaring on both sides. Then again you are taking the next one, you will get a cube is congruent to b cube mod m. So if you continue this process, then you will get a power x is congruent to b power x mod m, where x is a positive integer. So this is the third proof. So we are having these 3 proofs in our syllabus. So now let us discuss the first problem based upon these theorems or based upon these properties only. Okay. So we are given that 1 factorial plus 2 factorial plus 3 factorial and so on up to 100 factorial. So this equation, when it is divided by 15, what will be the remainder? This is the question. So now let us solve the question. Solution. See, we are given that 1 factorial plus 2 factorial plus 3 factorial plus so on up to 100 factorial. You can write it as 1 factorial plus 2 factorial plus so on up to 100 factorial mod m, right? Mod m. What is m then? Here we already know what is m. In the question itself, it is given that when this equation is divided by 15, then what is the remainder? That means you have to divide by 15, right? That means m is nothing but 15. This is the value of m. So now this equation mod m, that is mod 15. Now if you carefully observe, here you will get from 5 from here 5 factorial, 6 factorial plus so on up to 100 factorial. So in these series from 5 factorial, you will be having 5 into 3 in each and every number, in each and every term. Am I correct? In 5 you will get 5 into 4 into 3 into 2 into 1. That means you are having 5 into 3. Again in 6 you will be having 5 into 3. Again in 7 you will have 5 into 3 and so on like that. If you continue the process, each and every number up to 100 will contain 5 into 3. That means what? You will get this value as 15. 15 mod 15, you will get the remainder as 0. So these terms will completely divide by 15. So if you can eliminate these terms, right, so that you can easily find the remainder. Now we are left out with 1 factorial plus 2 factorial plus 3 factorial and plus 4 factorial, which is mod 15. Now here we will write the values of these 6 and 24, right? 1 factorial is 1, 2 factorial is 2 and 3 factorial is 6 and 4 factorial is 24, which is again mod 15. Now see here, 24 plus 6 is nothing but 30, right? 30 is divisible by 15, right? So you can also eliminate this 30. So again, if you eliminate this 30, then you will be remained with 1 plus 2, which is nothing but 3 mod 15, right? 3 mod 15. So again you cannot simplify this 3 mod 15, right? 3 mod 15 is again just we will get 3 only. So the remainder is 3. So the remainder is 3 in this case. So hope you understand. If not, let us once recap it again. 1 factorial plus 2 factorial plus 3 factorial and so on up to 100 factorial mod 15, because in the question it is given that it is divided by 15. So now from 5 factorial to 10 factorial, you will be having in each and every term you will have 5 into 3, which gives the value as 15. So in each and every term you are having 5 into 3 so that it is divisible by 15. So that's the reason you can eliminate this series, right? So now you will be remained with only this series 1 factorial plus 2 factorial plus 3 factorial and plus 4 factorial. Now if you write these values 1 plus 2 plus 6 plus 24, 6 plus 24 will be, it is nothing but 30. The value of 6 plus 24 is 30. 30 is exactly divisible by 15, right? So again you can remove those two series of 3 factorial plus 4 factorial. Now you are remained with 1 plus 2. 1 plus 2 value gives 3, which is 3 mod 15. Now you can't simplify further. So 3 is the remainder of the given series. Okay. Now it is clear, I think so. So now let us go into the second question, which is find the remainder when 16 power 53 is divided by 17, which is nothing but here 16 to the power of 53. If this number is divided by 17, if it is divided by 17, then what is the remainder? That is the question. So now what to do here? Whenever if they ask a number to the power of another number, that means if there are more than if there are the largest numbers are present in the powers, then the most basic thing first you need to do is you have to reduce to the least residue. That means what? 16, it is, this is the power of 16, right? That means if the 16 power is 1, then how will it divide 17 so that you will get the remainder what? That means what? 16 is congruent to 2 mod 7. Sorry, 2 mod 7. Okay. It is not 17. I am sorry. Let us take here once. Give me a moment so that. So here, I'm very sorry. Actually, the question is not 17. It is 7. Okay. The question is 7 here. So, it is not 17, right? It is just 7. So now 16 power 53, when it is divided by 7, you will get the remainder as what is the remainder? That is the question. So if you reduce it to the least residue, 16 to the power of 1 is congruent to 2 mod 7, right? Why 16 minus 2 is divisible by 7? It should be divisible by 7. In such a way you have to take the remainder. That means 16 minus 2 is nothing but 14, right? 14 is divisible by 7, which is 7 2s are 14. So you will get the remainder as 0. So this is congruent. So this is the least residue of 16. Now we are having a property which is, since a to the power of x is congruent to b to the power of x mod m, right? So from this equation, what can you do? We can just write it is as it is of the form a power x is congruent to b to the power of x mod m. That means what? 16 to the power of 53 is congruent to 2 to the power of 53 mod 7, right? So now that means 16 to the power of 53, when it is divided by 7, you are getting the remainder as 2 power 53. Now, after further simplification, how can you write 2 to the power of 53? It can be written as 2 power 3 into 17 plus 2. Am I correct? Because 3 into 17 is nothing but 51 exactly. 51 plus 2 is 53. So now you can represent it as 2 cube whole power 17 into 2 square. You can write it as 2 cube whole power 17 into 2 square, right? Now 2 cube whole power 17. 2 cube is nothing but 8. 8 mod 7 will get, you will get the remainder as 1. So 1 power 17 is nothing but 1 only. So there is no much difference. So now let us substitute this in the place of 2 power 53. That means 16 to the power of 53 is congruent to 1 power 17 into 2 square mod 7. Now 16 to the power of 53 is congruent to 1 power 17 is anyhow 1. So 2 square is 4. 4 mod 7. That means here you got the remainder as 4. So if you divide 16 to the power of 53 with 7, then you will get the remainder as 4. Okay, I think you are clear with the problem. So let's recap it once more so that it becomes much more clear, so that you can solve some other problems of same model. 16 to the power of 53, when it is divided by 7, what is the remainder? That is the question which we have. So now reduce the base to the least residue of modulus 7. That means 16 is congruent to 2 mod 7, because 16 minus 2, which is nothing but 14, is divisible by 7. So you can write it as 16 is congruent to 2 modulus 7. Now we are having this formula. A power x is congruent to b power x mod 7. By using this formula, you can write it as 16 power 53 is congruent to 2 power 53 mod 7. So now this is 2 power 53 is the remainder if you divide 16 power 53 with 7. But if you further simplify 2 power 53, you will get 2 power 3 into 17 plus 2. Which is nothing but 2 cube whole power 17 into 2 square. You can also write it in this way. Now 2 cube is nothing but 8. Correct? 8 8 mod 7, if you divide by 7, then we will get the remainder as 1. So 1 power 17 into 2 square. So 1 power 17 is nothing but 1. So there is no need to consider it, because if you multiply 1 with any number, you will get the same number itself. So 2 square is nothing but 4. 4 mod 7. So you will get the remainder as 4 in this case. So this is the problem. Now let us see one more example of the same model, so that it will be clear if you solve this problem. So here, find the remainder when 3 power 247. That means what? 3 power 247. When it is divided by 17, what is the remainder? Here in this case it is 17, previous case it was 7 actually. So now, the main thing is you need to reduce to its least residue, right? That is equals to, here mod 17 anyhow, least residue 3. 3 generally you cannot, the number of a should be greater than m, right? So that means let us take 3 cube. 3 cube is nothing but 27. 27 minus 10 is 17, which divides 17 exactly, right? So in this way you have to reduce it to the least residue. Let us write here 23 cube is 27, which is 10 mod 17. Now using this formula, a power x is congruent to b power x mod m. Using this formula or using this property, now this is 3 cube anyhow. If you take x value as, if you take x value as 4, then what does it becomes? 3 4, so it will be 12. Now we will just square on both sides. We'll just square it here. That means what? 3 cube whole square is equal to 10 square mod 17. That means we will get 3 to the power of 6 is congruent to 100 mod 17, right? Again, this 100 can be simplified, right? How can you simplify 100? If you divide 100 with 17, 17 6 it is, I think it is divisible when it is 17 is multiplied by 6 times, correct? So if you multiply 17 with 6 times, then you will get 1 or 2. So that you will get the remainder as minus 2 in this case. Because if you multiply 17 with 5 times, that means 17 5 is 85, which is not the nearest integer to 100. So that's the reason we are taking 6 in this case. So you will get the remainder as minus 2. That means you can also represent 3 power 6 is congruent to minus 2 mod 17, right? So now if you square this numbers, then you got minus 2 mod 17. Now if you do to the power of 4, that means what? 3 cube whole to the power of 4, then 3 cube, this is 3 cube whole to the power of 4, then you will get minus 2, I'm sorry, 3, this number, this equation you are doing to the power of 4. So now minus 2 to the power of 4 mod 17. So here it becomes 3 power 6 whole power 4. That means 6 4s is 24. So 3 to the power of 24. Now here, this is whole power 4. Anyhow, you will get a positive number. 2 power 4 is 16. 16 mod 17, right? 16 mod 17 means if you simplify this 16, you will get 3 power 24 is congruent to minus 1 mod 17. Am I correct? Because in this way, if you 16 is nearest to 17, but it is less than 17, so we are taking minus 1. So now generally if you write this equation like this, so I'm solving it this side so that the complete problem will be 1. So generally you can write 3 to the power of 247 is congruent to what? That means you will get the remainder here, mod 17. Am I correct? You will get the remainder here. So you can express 3 to the power of 247 as 3 to the power of 24 into 10 plus 7, right? That means what? 3 to the power of 24 into 10 into 3 to the power of 6 into 3 power 1, right? Because if you add 6 plus 1, you will again get 7. So 3 to the power of 24 whole power 10 into 3 power 6 into 3 power 1. Now 3 to the power of 24, here you got the remainder as minus 1. Minus 1 whole to the power of 10 is nothing but again 1 itself, right? Because whole to the power of 10 is an even number, you will get positive 1. So 3 power 6 into 3 power 1. So here 3 power 6 can be, you will get the remainder as minus 2, correct? So you can write minus 1 whole power 10 into minus 2 into 3. So now this is a positive number, and here if you multiply this, you will get minus 6. Here in this case, minus 6 will be changed as what? 3 to the power of 247 is congruent to 11 mod 17, right? Because why am I writing in this way is minus 6 is the negative least residue, right? It is a negative number. So change minus 6 to its least residue. Minus 6, if you change to the least residue, you will get 347 is congruent to 11 mod 17. So that means what? Here the remainder you get is 11. 11 is the remainder. When if you divide 3 power 247 with 17, then you will get the remainder as 11. So this is the one more question of the same model which we have. So I think it is clear. So let us meet in the next video with the new topic.